There are signals out there drifting through the cosmic ocean, whispering secrets in the language of the stars. Some of them have a clear source, a pulsar spinning like a lighthouse in the dark or a distant galaxy humming with energy. But then there are the others, the strange ones, the signals that arrive suddenly, unannounced, and then vanish. These are the phantom signals of the universe, unexplained radio bursts, mysterious pulses of energy. Cosmic echoes that might be the footprints of something we don't yet understand. Are they natural, a quirk of physics we haven't unraveled, or just maybe could they be something more? Let's take a journey into the great unknown and explore the most intriguing, the most haunting signals we've ever detected. The universe speaks in radio waves. Space is silent to our ears. If you were floating out there drifting between the stars, you wouldn't hear a thing. No sound, no wind, just the infinite stillness of the void. But space isn't truly silent. It speaks in radio waves, in pulses of light, in bursts of energy that travel for billions of years before they reach us. These signals don't need air to travel. They ride the fabric of space itself, moving at the speed of light. Most of them have a known source: blazing stars, collapsing neutron stars, even black holes feeding on matter. But every so often, something reaches us that doesn't fit any pattern we recognize. Something unexpected. Let's start with one of the most famous signals ever detected, the WOW signal. August 15, 1977. It was a warm summer night in Ohio, and at the Big Ear radio telescope, the universe was being listened to. The telescope had been scanning the sky for hours, waiting for something, anything, to break the cosmic silence. And then for just 72 seconds, something did. A radio signal, not just any signal. This one was different, strong, clear, unusual. It wasn't the random static of the universe, nor was it interference from Earth. It was a burst of energy at exactly 1420 megahertz, a frequency known as the hydrogen line, one of the key wavelengths astronomers had long speculated an intelligent civilization might use for communication. Why? Because hydrogen is the most abundant element in the universe. If you wanted to send a signal across the stars, choosing the frequency of hydrogen would be like lighting a beacon on the highest mountaintop, impossible to miss. The astronomer who discovered it, Jerry Amen, saw the data printout, circled the numbers, and scrawled a single word in red ink beside them. Wow! And just like that, the signal had a name. The WOW signal lasted a little over a minute. Then it was gone, and despite decades of searching, it never returned. Astronomers pointed their telescopes back to the same region of space, somewhere near the Sagittarius constellation, but they found nothing. No repeating pattern, no second pulse, just silence. This raises the question, what was it? There are only two possible answers. Either the WOW signal was a natural cosmic event, something explainable, even if we don't fully understand it yet, or it was an artificial transmission, a deliberate message from somewhere, out there. Could it have been an alien signal? The idea that the WOW signal came from an extraterrestrial intelligence is enticing. After all, it appeared exactly in the kind of frequency range scientists had speculated might be used for interstellar communication. And its intensity suggested it wasn't just background noise. It was aimed, as if coming from a specific point in space. But if it was an artificial signal, why did it only happen once? Perhaps it was an accidental transmission, a brief burst from an alien world that, for just a moment, happened to align with our telescopes. Maybe it was a deliberate message, a cosmic equivalent of a flare sent up in the night, but one that wasn't meant to repeat. Or maybe, just maybe, The signal has been repeating all along, but we're simply not listening at the right time. What else could it be? Scientists have spent years searching for an alternative explanation. Some possibilities include a natural cosmic phenomenon, perhaps an unusual burst from a neutron star or a distant quasar, but no known cosmic object produces signals quite like this. A secret human-made transmission, maybe a stray military or satellite signal bounced off something and reached the telescope. But the frequency of the WOW signal is heavily regulated. No Earth-based transmitters use it. A comet. In 2017, one scientist suggested that the signal might have come from a cloud of hydrogen surrounding a passing comet. But this idea is controversial, and most astronomers don't find it convincing. Decades later, the WOW signal remains one of astronomy's greatest unsolved mysteries. It stands as a reminder that the universe is vast, complex, and filled with surprises. Perhaps one day we'll hear it again. Perhaps somewhere across the stars, another civilization sent a message and we just happened to be listening at the right moment. Or perhaps it was just a whisper from the cosmos, a fleeting echo of something unknown, never meant to be heard at all. Fast radio bursts, the universe's ghostly whispers. The universe is full of noise. Stars explode, black holes collide, galaxies swirl and churn, sending waves of energy rippling through space. But in the midst of all this cosmic chaos, sometimes we hear something unexpected, something fleeting, something powerful, a single brilliant pulse of energy. Here one moment, gone the next. These are fast radio bursts, and they might be one of the strangest mysteries in modern astronomy. The first fast radio burst was discovered by accident. In 2007, a team of astronomers was looking through old telescope data when they found something that shouldn't have been there. A burst of radio waves, just a few milliseconds long, but in that tiny fraction of a second, it released more energy than our sun emits in an entire day. At first, no one believed it. It had to be a glitch, an error in the data. But then more were found. Bursts that seemed to come from billions of light years away. Bursts that arrived suddenly and then vanished. The universe was whispering, and we had no idea why. Where are they coming from? Fast radio bursts, or FRBs, are unlike anything we've seen before. They don't behave like pulsars, those rapidly spinning dead stars that send out steady, predictable radio signals. And they don't match the patterns of supernovas, which release energy over days, weeks, or even months. Instead, FRBs are unpredictable. Some have been detected only once, a single pulse never to return. Others repeat, flashing over and over again as if something is sending them deliberately. One of the most famous, called FRB 121102, repeats regularly, hundreds of times, and it comes from a tiny galaxy more than 3 billion light-years away. Think about that. 3 billion years ago, when this signal first began its journey, Earth's land was barren. The first life forms were still swimming in ancient oceans. Dinosaurs wouldn't even exist for another 2 billion years. And yet, only now, that burst of energy is reaching us. Scientists have spent years trying to understand what could create such powerful, yet short-lived signals. And while we don't have all the answers, there are a few possibilities. One idea is that FRBs come from magnetars, a rare type of neutron star with an extreme magnetic field. Magnetars are some of the most extreme objects in the universe. Their magnetic fields are 1 trillion times stronger than Earth's. If one were even a fraction of a light year away, it would erase the data on every hard drive on the planet. And sometimes, their magnetic fields snap like an overstressed rubber band. When that happens, they release enormous bursts of energy, exactly the kind of bursts that might explain FRBs. Another theory is that FRBs are the result of neutron stars crashing into each other. Neutron stars are the dense, dead cores of once massive stars. When two of them spiral toward one another, they release a burst of gravitational waves, followed by an explosion of energy. This could explain some of the one-time FRBs, those signals that appear once and never return. And then, there's the idea that FRBs could be something else entirely. Some scientists have speculated that they might be artificial, perhaps a sign of an advanced civilization using powerful energy beams to propel spacecraft across the cosmos. The idea is based on a concept called light sailing, where massive bursts of energy, like lasers or radio waves, could be used to push a spacecraft across space. It sounds like science fiction. But if humanity were to explore interstellar space one day, it's exactly the kind of technology we might use. So if we can imagine doing it, could someone else already be doing it? One of the biggest mysteries of FRBs is why some of them repeat. Most natural cosmic explosions, like supernovas or neutron star collisions, are one-time events. They happen once and that's it. But repeating FRBs keep coming back. Could they be caused by something we haven't even considered yet? Or are they signals? A cosmic beacon flashing in the dark, waiting for someone to notice? For now, we don't know. Fast radio bursts are still one of the greatest cosmic puzzles of our time. They could be the echoes of dead stars, the shockwaves of colliding worlds, or something even stranger, something we haven't even imagined yet. Tabby star, the flickering enigma. Most stars shine steadily. They flicker a little, maybe dim slightly if a planet passes in front of them, but for the most part, they follow predictable rhythms. But not Tabby star. Tabby star does something different. It dims, not just a little and not in a way that makes sense. Sometimes it loses 5% of its brightness, sometimes 15%, and at one point it dropped by 22%. That might not sound like much, but to put it into perspective, if Jupiter passed in front of the Sun as seen from Earth, it would only block about 1% of its light. Whatever is dimming Tabby's star isn't just a planet, it's something much, much bigger, and the strangest part, the dimming isn't regular. It doesn't happen on a predictable schedule the way a planet orbits a star. Sometimes it fades for a few days, sometimes for weeks. Sometimes it brightens again as if nothing ever happened. It's erratic, unstable, unlike anything we've seen before, and to this day no one knows why. Tabby's star was first brought to the world's attention in 2015 by astronomer Tabitha Boyajian and her team. They had been analyzing data from NASA's Kepler Space Telescope, a mission designed to search for exoplanets by looking for tiny dips in a star's brightness. Most of the time, those dips are small and occur at regular intervals, signs of a planet passing in front of its star. But Tabby's star didn't behave like that. Instead of a smooth, predictable pattern, its brightness dropped in huge, irregular chunks. And whatever was causing it wasn't just passing in front of the star. It seemed to be blocking large portions of its light in an unpredictable way. Naturally, astronomers wanted to find out what was happening. When Tabby's star first made headlines, one of the most exciting and controversial theories was the idea that we might be seeing a Dyson sphere in progress. A Dyson sphere is a hypothetical megastructure, a vast shell of solar panels or satellites built around a star to capture its energy. If an advanced civilization were harnessing the power of its sun, it might build something like this, a structure so large that it could block significant portions of the star's light in irregular patterns. It's a mind-blowing idea, and while most scientists are skeptical, they haven't completely ruled it out, because whatever is happening around Tabby's star is weird. To make things even stranger, astronomers discovered that Tabby's star has been dimming over the past century. This isn't just a recent event. Historical data shows that its brightness has been fading slowly for over 100 years. That makes it even harder to explain. If it were a random dust cloud or a passing swarm of comets, why would it keep dimming gradually over time? And why is there still no pattern? Tabby's star remains one of the greatest cosmic mysteries of our time. It isn't behaving like any other star we've observed. It flickers, it dims, it brightens again, seemingly at random. And no single explanation, natural or artificial, has been able to fully account for what we're seeing. Maybe in time we'll find the answer. But for now, all we can do is watch and wonder. The Lorimer Burst, a signal from the deep past. Some signals travel for years before reaching us, some for centuries. And then there are signals like this one, ones that have been on a journey for billions of years. A single flash of energy racing through the void, crossing galaxies, outliving stars, traveling across time itself. This is the story of the Lorimer Burst, one of the most mysterious and powerful radio signals ever detected. A signal that began its journey before Earth even existed, and one that still leaves us wondering, what could have caused it? It was discovered in 2007 by accident. Astronomer Duncan Lorimer and his student, David Narkevic, were combing through old telescope data from the park's radio telescope in Australia. They were searching for pulsars, rapidly spinning neutron stars that send out rhythmic radio pulses. But buried in the recordings, they found something far more unusual. It was a signal, a powerful burst of radio waves. It lasted no more than 5 milliseconds, an instant. But in that tiny fraction of time, it released more energy than our sun produces in 30 years. And the most extraordinary part, it had been traveling for over 7 billion years before it reached us. That's older than our planet, older than our sun, older than the very conditions that would one day allow life to emerge on Earth. When this signal first began its journey, the Milky Way was still young. And yet, across that vast ocean of time and space, it kept going, moving at the speed of light, untouched and uninterrupted, until one day, purely by chance, it was caught by a radio telescope on a small blue planet that didn't even exist when it was first sent. But what could create something so powerful, yet so brief? The most likely explanation is something catastrophic. Perhaps a neutron star, the incredibly dense corpse of a once massive sun, collapsing into a black hole in its final moments of existence. That kind of event would release an enormous amount of energy in an instant, like a cosmic flashbulb igniting and fading just as quickly. But there's a problem. If it was a neutron star collapsing, we should never see another burst from that same location again. And yet, since the discovery of the Lorimer Burst, other similar signals have been found. Some appear only once, but some repeat. That means whatever is causing them isn't necessarily a one-time event. Maybe it's something even stranger, like a magnetar, a rare type of neutron star with a magnetic field so intense that if one were even a fraction of a light year away, it would erase every hard drive on Earth. Sometimes, the intense magnetic fields of these objects twist and snap, releasing enormous bursts of energy. Maybe that's what we're seeing. Or maybe, just maybe, these bursts aren't natural at all. Some have speculated that what we're detecting could be artificial, intelligent signals, or at least a byproduct of some technology beyond our understanding. Imagine a civilization far older than ours, using beams of energy to propel starships across the cosmos. If such technology existed, it might create brief, powerful flashes, ones that, from our perspective, look exactly like the Lorimer Burst. It's speculation, of course, a mystery wrapped inside another mystery, but the truth is, we don't know for certain what caused this signal, and that's what makes it so remarkable. The Lorimer Burst was the first of its kind ever detected, but since then we've found hundreds more. Some appear only once, like whispers from the depths of space. Others repeat, like a message sent on a loop. But here's the thing. If the Lorimer Burst took 7 billion years to reach us, that means there could be more signals on their way right now, still traveling through the darkness, still making their way across the stars. Perhaps another burst, even older, is just now reaching the edge of our galaxy. Perhaps at this very moment, a signal is passing through the cold void of intergalactic space, heading straight for us. And all we have to do is listen. The cosmic messages we haven't heard yet. For all the signals we have detected, there are countless others still drifting, still traveling, still waiting to be heard. Perhaps, right now, a message is making its way toward us. A burst of radio waves from another galaxy, a whisper from a dying star, a signal that will change everything we thought we knew. Or perhaps the universe is speaking in ways we haven't yet learned to listen to. Whatever the answer, one thing is certain. The cosmos is alive with stories, with mysteries, with messages written in the language of the stars. And all we have to do is keep listening.